All right. Grade 12, we continue the second session. And then we'll be doing finance now, but specifically grade 11 finance. Let me just check if it's visible from the video. I'll come back to you guys. Looks like we're good. Let me just share the link with the rest of the class. All right. We'll be revising this. We'll start with the effective interest, and then I'll also give you some few examples that are required, maybe to change from one interest rate to the other, and also the other wording like nominal interest and so forth, so you can be able to get the financial vocabulary when it comes to your paper one. And then we'll also be doing your book values, your using your reduction balance, and then we'll move into timelines using the compound growth, and then let's jump straight into it. Right. Normally we as grade 12s we rely on our formula sheet. So when it comes to the effective interest rate per annum or the effective interest rate, let's take a look at what we have here. I'm going to give you, before we start solving the problem, we have a way of converting from one interest rate to the other. Right. So this is the formula that we use to convert from one interest rate to the other. Let's say you are given an interest rate of compounded monthly. You need to convert it to compounded maybe semi-annually. And then the interest rate that you are given, let's say, let me just take this one. For example, before we answer the question, let's say we have 11% compounded monthly. I want to see what is the interest if it was to be compounded semi-annually. So I'm going to say 1 plus what is given to me. What I want is semi-annually, so I don't know the interest rate. And then semi-annually, you just ask yourself, how many semi-annuals are there in 1 year? You always compare to 1 year. So it's just 2 of them. And then n will be to the power of 2, which is 1 times 2. And then on this side is what is given to us. We have 11.5. So remember, this is 11.5%. So we're going to take this and divide it by 100. So that it cannot be a percentage. And then this will be 0.11. You can also verify. You'll see in most instances you will be required to press in your calculator to get the values, because just to save time, just press the values. We'll do the method, you press the values just to verify. And then it was compounded months. How many months are there in a year? It's 12. And this will just be 12. This is what this N means. The interest rate which was compounded in a certain period. So if it's semi-annually, you ask yourself how many semi-annuals are there. Remember, semi-annual is half a year. How many half a years do we have in 1 year? It's 2. So always compare to 1 year. And then in 1 year, how many semi-annuals are there? Then you multiply by 2. So in most instances, the number you get here, the number you get there will actually be equal, but not just in these problems. So we are converting from 11% per annum compounded monthly to compounded semi-annually per annum. Yeah? So when you simplify this, this will be, you square both sides. So you have 1 plus I over 2. You square root both sides. And just put the square root this side so that we can see, which will be equals to the square root of 1 plus 0.115 over 12 to the power of 12. And then I'll take the 1 to the other side. So I over 2 will be the square root of 1 plus 0.115. I like using the calculator at the end so I don't lose in any decimals. So it's very important in finance to round off at the end so that you don't lose any sense, because nobody likes to lose money. Yeah? Then we transpose this 1 to the other side, so it's going to be a minus 1. It's not inside the square root. And then we can multiply by 2, so our I will simply be 2 of the whole thing, the square root of 1 plus 0.115 over 12 to the power of 12 minus 1, and then multiplied by 2. And then when I get here, then I can just start saying, okay, let me just press this in the calculator now. It is safer for me to press in the calculator. And I'll say 2, put it in the calculator the way it is. Open brackets. And then I will have the square root of. And then inside the square root, I will have 1 plus, and then 0. 1 plus 0.115 divided by 12, and then close brackets, then to the power of 12, and then we move in the minus 1, not delete. Then minus 1. I don't want it to be there. Let's see. I don't want the 1 to be inside. Okay, let me just close bracket. Close the bracket, so it means that I'm going to have to subtract 2. So my I will simply give me 0.11779. So I to 2 decimal places will simply 0.1, and then this will be 2. But if I want to compare it with the other two, just to see, I'll take the 3 decimal place because that's already in 3 digits. So I'm going to say if I multiply this by 100, it will be 11.8% per annum. CP will mean compounded semi-annually. So you see that if your money was to be compounded semi-annually with the same interest rate, if you convert it, it means semi-annually it will have 11.8% per annum. It will be the same interest rate as 11.5. It's just that this one is a bit higher because it's only compounded twice. This one is compounded 12 times. So this is just what I'm trying to remind. This you will not find in the formula sheet. You need to remember it. If there's one thing that you have to remember from grade 11 is this formula that we use to change our interest rate from 1 interest rates to the other, specifically those that are compound interest. So just be aware of that. And then the reason why I'm showing you that, because you might need it somewhere else. And then I will explain what effective interest rate is. So we'll save this and then we'll share it with you guys. Just remember that this will be required for you guys to know. Thank you. And then let's see. For effective interest rate, the formula now becomes a bit special, because effective interest rate is the interest rate per annum. So it means that the same formula that we had, that had 1 plus I to the power of n over n to the power of n equals to 1 plus I to the power of im divided by m multiplied by n. When it comes to the effective interest, I'll still use the one with m and on the other side. Remember, this is per annum, so 1 plus effective interest over is per annum. So how many years are there in a year? Just 1. So n is also 1. Then equals to 1 plus whatever is been, the interest rate has been compounded to you. And that's, if it's compounded monthly, this will be simply 12. And if this will also be divided by 12. But they need to tell you if the interest has been compounded monthly or semi-annual. If it's semi-annual, it's going to be 2, then this will be 2. If it's monthly, it's 12. If it's quarterly, then you know how many quarters in a year? We have 4 of them. So this will be divided by 4 to the power of 4. The reason why the formula of effective interest now becomes, you can start it like this if they ask you specifically for the effective interest. 1 plus I effective, because this is to the power of 1. It's just 1 plus I. You can just call it the nominal interest or whichever which is given to you. Just remember that the reason why we have this formula, it has come from the general formula. So if they say effective interest, you can write 1 plus I effective, or you can still use this one, but do remember that this comes from per annum. Just get to remember that. So you are going to be given almost, I think 90% of the time, when you're going to be tested in grade 11 finance, they will ask you about the effective interest rate. So for this problem, our effective interest rate because we've now made sure that we understand where the formulas are coming from. Remember, this formula will not be given to you in the examination. It's not there in the formula sheet. You can also verify in your formula sheet. Look at the formula that you have for finance. This one is not part of it. So you remembering that formula will grant you a mark automatically. So let's answer this question now. It will be, let's write the formula before we start substituting. So this will be 1. Is it coming effective interest rate per annum? If an investment interest rates of 5% per annum is compounded monthly. So this will just be 1 plus interest rate 0.115 divided by monthly. I mean, months are there in a year, 12. And then you can simplify this. The good thing about this one is that it's just the power of 1, so it's simply we just do the effective interest and then isolate the effective interest by transposing 1 to the other side. So our answer will be 0.115 over 12 to the power of 12, and then minus 1. If I press this on my calculator, it will give me open bracket, and then 1 plus 0.115 divided by 12, and then close bracket and go back, and then minus 1. Don't be lazy to press the calculator, and you put in what you see there. And try to be hysterical. Try to do it with your head. You must have a calculator. So when you practice finance, you must have a calculator. You cannot practice finance without a calculator. That's why I brought my calculator. Normally I don't use a calculator, but today I'm using a calculator because I want you to get used to practicing your finance with a calculator. And then the other thing is that if you're going to practice with a calculator and you get to the examination, and then now you have to use the calculator for the first time, it's going to waste your time because you're still learning to use the calculator. You don't even know. Sometimes somebody borrows you the calculator, doesn't have the numbers. You have to figure out the numbers, so it's gonna waste your time. So it's best that everybody has a calculator. Those who have calculators, you must make sure that you buy those calculators. We also have calculators that we can offer for you guys to use, but make sure that you take full responsibility of those. So our effective interest rate is 0.12, and then we can just multiply by, and say, if you multiply this by 100, then this will just be 12.2% per annum. It's compounded per annum. You can just say per annum. I wrote this on paper so that you can see that inside these formulas we are using I, but the interest rate is actually 12.125. So once you see percentage there, you must know it's actually the interest rate, and then this one is the effective interest, which is one that we put in our calculations. So never put anything in terms of a percentage. I don't know. There's a child outside. I don't know. It's looking for you, ma'am. All right. So that's how we do the interest rate. Let's see if we can have another problem that we can do. Let's look at this one. We need to calculate the effective interest rate if the interest is compounded at 5% per annum, compounded quarterly. So it becomes also very straightforward. We now know the formula for let's move you here quickly. We now know the formula will be 1 plus effective interest. We know why, because effective interest is per annum, which should be equal to 1 plus I to the power of m divided by m to the power of m. So the effective interest compounded at 5% per annum, compounded quarterly, will simply be 1 and then this was actually 5%. We divide this by 100 so that you can get rid of the percentage. This is 0.05, and then it's compounded quarterly. How many quarters are there in a year? It's just 4 of them. It's like terms. Ne?